Hi everybody. Today's topic, the ASD from Securiton. Just a quick refresher on programming and understanding where the settings for programming is coming from. This is based on the training I've had and just over 5 to 6 years of experience and what I've seen commissioners do wrong on site. So I would actually like to start from the basics point of view, and that is where the design starts off. So right here I've got the pipe flow program, and right off when I open it up, I will go to my 25mm ABS red and I set that as the default, simply because that's the tubing we get here in South Africa and it makes your bill of quantities much easier. Starting off, I've got this small design. So what I'll do is I'll put a pipe down, I'll add an accessory which will be the filter, zoom out slightly. I'm not going to go into the details of exactly how to scroll and all of that. That's something you can do in the training. This is based just quickly to show you how to get to everything and how the whole design is being set up. Okay, so there's a basic layout of what I want. So I'll go for the first pipe, meter down, another half a meter down, half a meter over. Then I want to put about 2.5 to the ceiling, 3 meters across, and we've got 5 meters spacing between the lines, so this will be 2.5 for now, and a 5 meter. We'll see why I've got 2.5 in a minute. And I've got my 2 pipes that side. Eventually we're going to have another one sitting that side. I know this is a 30 meter section, and what I'm going to do is I'm simply going to delete that pipe. I'll right click on this one, I'll say at multiple sampling points, max distance of 5 meters between each point. There's my design. So I'll click on it, copy the pipe, and I'll paste it onto that point. Okay, so the one leg of this design is done. I'll quickly see if I can calculate this. Right, it says sensitivity of smoke sensor, constellation sampling is admissible. So I'm gonna ramp it up slightly, see if I can get it to optimize. We have still 17, it must be about 20 to optimize. So we might just be out of tolerance for this. Yes, so it's not happy at all. Okay, let's keep this for now. What I'm going to do is at multiple sampling points, I'm deleting the original points again, and I'm going to work on 7 meters for that one. Delete that, so I've got less holes. See if I can make the transport time better as well. I'm still well within design requirements and regulation. Right, so now I've got class A at 20. So add the second leg, which would be that side. So we're going to copy that, paste it, click on this pipe as soon as you can get it there. That pipe, mirror the selection and press the delete button. And you've got it. Now I can again optimize. And we should have all of them green. Okay. Now, this is where it becomes very important. These values at the bottom is what we're going to set up on the ASD. So if we go over, the design is done, normally gets printed, the installation guys will install it as per the design. And when the commissioner gets to site, he will need to set it up, either class A, B, or C. So let's go over to the aspirators themselves. Let's go to the aspirator themselves and connection, select device. Now, you can see easy the airflow is, there's an airflow problem. If you go to the bottom here, and this one is not been set up at all. So first of all, make sure that your pipes are all sorted. There's no breaks, there's no leaks. It's done exactly as per your design. That's the commissioner's job as well. Make sure your piping is done correctly. You've got the correct number of holes, your hole sizes are correct. That's part of your job. It's one of the things I see a lot. Commissioners just go to site, plug in a laptop, download the program, walk off. They're not even downloading the correct information. You need to check this. Even if it's just a random check here and there, you need to make sure this is correct. Right. First of all, go to extras, synchronize your time. Okay, this is right. So synchronize my time. Secondly, I see channel is off. I'm not sure why that is off. So let's go to settings. Everything is fine here. So both channels are on. General latching. I'll go for all the settings just now. Isolation. See, nothing is isolated. I'll see now what the channel is off. Okay. So let's go to parameters. Okay, here's the reason why it's off. Program A11, it's only one channel. This is when you get the aspirator, you will have these pre-programmed channels set up. We're going to a programmable X1. That's what we want. First of all, you get activations, you get alarm 2, alarm 1. So let's just minimize all of these. Okay. You get fan level 1. In our programming, we said we're going to run 5 fan level 5. So let's set that to 5. Then we're going to go to alarm level 2. If you're not going to use it, you can skip this. But normally that value there must be higher than this value. So what did we calculate on this side? So alarm levels we calculated, and we're going back to the paperwork. For a class A, it was 0.02. And that's the value we need to add there. Same on this side. It's done already. And you can just go around doing it to all of these settings. Although we might not use day and night settings, you can just add it in there. If you decide to use alarm 2, you can, this alarm 2 must always be higher than that one. Okay. For now, I'm going to write all the code back to the aspirator. So what you will start hearing is the aspirator will probably ramp up. It will enforce all these settings. You will get faults. We'll start getting airflow faults and all of that. You can ignore it for now. We don't use cascading, and latching is if you want a unit to latch. Say fire mode, you want to latch until somebody presses reset. A lot of times aspirators are installed in places where your personnel don't always go. Especially in cold rooms, it's installed up into the roof void. There I normally disable the latching part. So when the aspirator doesn't detect any smoke again, it will go out of fire alarm automatically, although your fire panel will always latch on an alarm. Okay. 3 signals. This is same with most aspirators. You got the percentage of your alarm signal. So just know this is a percentage of your alarm cycle. It's got nothing to do with your alarm 2. Okay. With delay, again, you've got latching. Always, I like to keep the latching deactivated. Doesn't make sense to latch that, and every time the client needs to open a unit or whatever to reset it. You can install a remote reset on the aspirators. I've not seen that being used a lot for your airflows. In data centers, it makes a huge difference. Data centers with remote crack units where your air is being forced into the room, and then at certain temperatures, certain stages, the air changes, the air pressures differ. You need to adjust these accordingly. This is all 50%. Normal buildings where there's no forced pressure, no air cons, you've got a storage facility, 20% is more than sufficient. Oh, sorry, this is dust. 50% dust should be still like that. Ignore offset. So 50% dust is fine. That, yeah, fault cycles on dust. Keep it to 50%. Keep it activated so it doesn't go in and out, and also latch your dirty faults. You just make sure that it doesn't go in and out of fault all the time and you don't know what's happening. Airflow, this is what I'm about. We've got a 20% deviation. Now, huge data centers with large HVAC units. I've seen a deviation when start and stop of HVAC units of up to 35%. That also depends on where your aspirators is mounted. If everything is mounted inside the room, it doesn't give you that huge issue, but it does happen where you've got an aspirator in the floor void, room and ceiling void, and you blow air in the cold air, hot oil systems, you do get this phenomena. So what I've found is at 35%, you are safe. Anything less than that, you tend to have issues when HVAC units, winter, summertime startup, go down. Okay. These also do not latch. So this is all your parameters set up, and you've written it to the aspirator. Relays. If you don't have a relay board on site, extra relay board, these settings, all of this is not used. It just sits there. You can set them on, off, doesn't matter. You can write them to the panel. And they're not going to do anything if there's no relay board. If you do have one, you can custom set it up in accordance to all the signals here on the left-hand side. Okay. These are standard. You can't change those. This is the onboard relays. Project description, we can change the code here depending on what aspirator you've got. You can change all the names. When you pull event lock, this will actually state on the event lock as well. Settings. Reset device. So you can have the reset button front activated or disactivated. Clock fault. If there's if the system experiences a wrong time setup, it can go into fault. General latching, you can have all the latching enabled or only those that you've selected. I like to keep this off, so we only activate those selected. Heating time, that's for freezer rooms. You can have a heating probe in each sampling hole, and when the aspirators are seeing a drop in airflow, it will actually heat those sensors. You can set it for 1 minute, 2 minutes, and so on. Also something I haven't come across a lot with the way we install sampling tubes, actually it's not needed. Memory card interval, if you've got a memory card installed, this is at the 1 second interval, it will save events. Again, if you want less events, you can actually have set it up later. Sorry. With the peak memory, yes. That is where when you hit peaks, it will actually, instead of going to 1 second, it will hit those peaks, it will lock that immediately. Channel 1 on, channel 2 on, we've got both of its SSDs. Don't use other ones, always use the SSD ones. That is what we use on what I've seen used mostly. I've had issues selecting of the other ones. You can deactivate the channel as well if you've taken the SSD out, but you will have a fault on the aspirator. Okay, events, you can store all the events. Auto learning again, you can auto learn for a day and it will actually give you an auto learn signal which you can recover from extras auto learn results. So if you select that, it says off, duration 1 day, elapsed, and then smoke levels that it actually picked up over those 1 days, which you can use as well. Okay. Day night, in this unit is off, we're not going to use it. You can put day night to clock. Fire alarm control panel, that's if you connected with the security fire panel, or OEM mode input. So you've got input on this aspirator which you can set to day night, which can be triggered from a fire alarm panel as well. In this case, we're keeping it off. Okay. Then you've got event memory. We can recover all the events. And in my case, you've got networking. So if I've got a networked aspirators, I can pull events from all the aspirators. Now let's go back to the live graphic. Currently, it should be off the charts. Got currently happening sampling by breakage, which just means our airflow is too high. Now we've checked the piping is all fine. Also note when you've changed the fan levels, give it about a minute to stabilize. Okay, so after you've stabilized, then only can go to extras and initial reset. So yes, and we'll actually bring all the signals down to 100% airflow at the bottom. You see my fault just disappeared as well. There's no faults. And the system is basically commissioned. So what you can see here immediately is my alarm signal is 1%, my alarm 2 is at 1%, alarm is at 0.02%, which is in accordance to my design for a class A. If it would have been a class B or a class C, I would have added 0.06 or 0.34%. In this case, we want a class A, so it's 0.02 there and 0.02 there. Our pre-signal 70, 50, 30, and we can see we've got a 0 at pre-signal for now. There's no alarm issues. Airflow is 100%, dirt is 6%. On the second channel, probably because it was off the whole time, still 0 at dirt, but the rest is all well as well. Let's just scroll through the rest of this quickly. Under extras, you can do firmware upgrades. There's a whole document about that. I might do it in one of the videos later on. We've done synchronized time, we've done auto learning, isolation. If you need for any reason to isolate one channel, you can actually isolate it, write it to the unit. It will tell you the fault will be triggered. And as you can see, if we go out here, isolation 1, so this channel is now isolated. Okay, there's also a fault been triggered, saying isolation, and the fault relay will also be on. You de-isolate, you can go back there, activate it again, write to panel, and it will just start up. Second relay test. This is commissioning testing. So there's two ways of testing it. We can activate an alarm by spraying the sampling tube, which I recommend, doing the last hole, the very furthest hole, and then using the SANS, in South Africa, the SANS requirement for testing the time for the alarm to activate. If you just want a quick test, seeing the guys have wired everything correctly, you can actually on the main board. So this is the main board relays. This is the relay interface module 1 and relay interface module 2, if you've got that connected. So I can say fault, and I can say start. Relays are activated, so I can click, and then the relays will trigger. So this now triggered the fault relay. We want to take it off. Again, remove it, start, we'll remove the relay. You can do the exact same one with alarm 2 and alarm 3. You can write it and we'll actually activate those relays. Remove it, start again, and we'll just silence it. Okay. You can select all of them if you want to, you can select none. Optional equipment, read, we've got nothing extra. This is where you can see what the relay cards or memory cards, whatever is installed. This unit doesn't have any extras. Trigger event. This is very similar to the relay one. Only difference is we trigger this on the SSD itself. So we can tell the SSD to say go into alarm. It will trigger, and we'll see if it goes all the way through all the electronics back onto the relays. So you see it went to your alarm this side, and your alarm should go off. You can actually then push it off again. And it went out. Okay, initial reset we've done. And that's it. One thing to note, your adapter settings. This is nothing to do with the ASD. This is just quickly on the software. One of the questions I have is guys going to site trying to connect to the aspirator and they cannot connect. Okay, the reason for that is on USB it's easy. When you have Ethernet, disconnect your Bluetooth, disconnect your Wi-Fi, all of that. Only leave your Ethernet port on when you connect to it. The reason for that is it automatically detects how to connect to the aspirator via Ethernet, and for some reason on some machines it tries to use Bluetooth and it tries to use Wi-Fi, which will not work, and it just comes back cannot connect. So disable all other networks on your machine, only keep your Ethernet on. That's one of the big issues guys are having, and it always will. Okay, what else? You can save your configuration file. A lot of guys don't do it. Best is to save it. I'm not going to save this one. Save it and then print it out and add it to the documents. So if you have a reference when you go to site and you need to check something, instead of connecting the laptop on, you can actually work through the documentation just to make sure what you've done is correct. Even the guys servicing can go through, check the documentation, and then when they put their machines on, confirm that everything is still as per original design. Okay. That's basically the short of it. If you got any questions, drop it in comments below. I can get to it. The main part is basically take your sheet, take your settings that was designed for class A, B, or C. And note it's not always the highest one. Your designer will tell you it was for class A, class B, or class C. So you can know what needs to happen. Also, the guys designing, something I didn't show here. Just press the wrong button now, I need to wait again. Okay. When you set up your name stuff, your naming convention, clients, all of that, please, under your optimization, select the channel. This will reveal on your documentation what the commissioner must do. So if it must be class A, select class A, save it, and then do your optimization. And that way, when it looks at the documentation, it will state the design requirements. That's one of the things that most guys doing designs leave out. And if the commissioner doesn't know what to do, he will just select class C because that's what's on the design. So it now states class A, and the guy who reads the documentation will see class A. Do you want to generate? Okay. So again, quickly, alarm 2 signals, if you use it, those the sensitivity percentage must be higher than your alarm levels. If I go, just want to check something, if I go 002, it will actually complain. If you put your mouse over it, it will tell you it must be 20% above alarm. Okay. Now it will tell me it's written, so if I write it, it will go into alarm. Your flow arrangements or flow faults, data centers 35%. Any other place, warehouse, I would go down to 20%. Because you do not get airflow differences between floor voids, ceiling voids. It's just a ceiling and there should not be any differences there. Okay. Relays, you can change your relays. Project description, put your naming of the aspirator, where it is, location, all of that, which will appear on your event reports. Settings, it's self-explanatory. And then event memory, you can draw all event memory, you can draw all of that or just some of it. And networking. I hope this made sense. Like I said, any comments, drop it below. If there's any other panels that you would like some refresher course information on, let me know as well. I'll see if I can get hold of those panels and drop you a video. Thanks, goodbye.